In our previous class, we started discussing about hello, getting echo.
Someone logged in with two devices and they are in unmute position. Naresh.
Naresh,
Yeah, yeah.
can you please check? Okay. So yesterday, we started discussing about disadvantages of our RIP protocol, link state protocol introduction part, OSPF characteristics, OSPF router ID, and wildcard mask configuration. That's all. So today, we'll continue with some advanced level like OSPF 7 states, neighbor states, OSPF terminology, OSPF tables, metric, packet types, single area, multiple area, router types. These are all the points we'll try to cover today. OSPF neighbor states. So how exactly OS will form the neighbor? This is R1 database table, it is R2 database table. Now between these two routers, if we configured RIP protocol, RIP version 2 protocol, how RIP protocol works? Blindly, whether neighbor is active or not, it will not check. It's just simply if you configure RIP, this complete routing table, it will send as update actually. Even if neighbor is down also, it will still send update packet. We know that, right? Because it's periodical updates. In case of OSPF protocol, not with RIP, if it is OSPF, how OSPF works? Even if you configure OSPF, OSPF also will do the same. Blindly directly send the database packet to neighbor? No. So OSPF first will discover neighbor. A neighbor relation has to be established. Neighbor table has to be formed. Once neighbor is established, then database exchange. So to discover the neighbor, to maintain the neighbor, OSPF will use one mechanism called hello packet mechanism. Correct? So these states are in 7 states actually. OSPF 7 states. The first state, neighbor is not established. We call it is, so R1, R2 are not neighbors. Call it is down, down state and both sides. Down state. This is the first state actually. Second state is initial state. In initial state, R1 will send message to R2. Hello R2, I am so and so device. It will send message actually. I am so and so device means router ID. I am 17, right? Text. I am 17.1.1.1. Three interfaces, highest IP 17.1.1.1. R2 also will send reply, yes, I am 192.168.1.1. So this is what exactly happening in second state, which we call initial state. In third state, two-way. Two-way state, hellos are exchanged. Hellos are seen actually. Will send hello packet, will receive hello packet. Means neighbor is established. It will build one table called neighbor table in two-way state, which is third state. 192, 168, 1.1 is the neighbor for R1. For R2 neighbor, 17.111 is the neighbor. So neighbor tables are built in third state, which is two-way. Once neighbor is established, now the database has to be exchanged. So that state we call exchange state. State is exchange. Once neighbor is established, we'll start exchanging actually. Okay. But before exchanging, they are going to decide to exchange. There is a fourth state. Exchange start. Call xstart. Xstart state. So what exactly happening in xstart state is R1 router will send R2, you take my update packet first. R2 will say, no, you take my update packet first. They're deciding to exchange action. So finally, which router has to give first update packet? A router which having a highest router ID will be the master. Another one is slave. Master and slave elections is happening in fourth state. R2 192.168.1.1, R1 17.1. So R2 has highest router ID. R2 will be the master action. R1 is slave. So R2 has give first update packet. So this is what exactly happening in fourth state, which we call xstart. Exchange started, not exchanging. Actually, in fifth state, the exchange. In sixth state, networks are loading. See, router 2 is giving update packet to R1. What network? 16 network, 192. 16 is already available, it will ignore it. So it will update only 192 as OSPF update. War out 192, 168, 1.0 network. So router 1 is loading the networks. We call it is loading state. And sixth one, R1 will send update to R2. 16 is already available, 190 is already available. So which networks will load 17 and 10? O routes. 17 dot network, O routes. 10 dot network. So we call it is loading state. Now compared to R1 and R2, both are same database. So once similar database, then we can call it is full. Neighbor is established fully, called full state. So this is how exactly between two routers, neighbors is been forming actually. Downstate, initial, two-way, xstart, exchange, loading, and full state. It's clear? So OSP of 7 states. Down, initial state, two-way, Xstart, exchange, loading, and full state. Okay. Next point, same like this. Anyone tell me what is the first state between two routers, neighbor state? What is the first state? First state in
Down.
OSP of 7, down state. Second state,
Initial.
what exactly happening in initial state? Router IDs. I am so and so router, you are so and so router, the exchange, right? Okay. Third state,
Two-way.
two-way. So what happening in two-way state?
A hello packet.
Hello packets. What is exactly hello packet contains? The name we call it is a hello packet, but what actually hello packet contains? HELO, hello is a
This seen
yeah.
seen a router ID.
So OSP of hello packet contains about area ID. Area ID. What is the default area ID?
0.
0. And next, network ID. Network ID. Subnet mask. Hello timers. And dead interval timers. Hello and dead timers. Okay. Hello and dead timers actually. Authentication. The point is, this authentication is optional. Is optional parameter. Remaining all are mandatory. So these all parameters OSP of hello packet contains. Very important. So OSP of hello packets contains area ID, network ID, subnet. Today we'll discuss about areas concept. Okay. Now let us check between hello packets between R1 and R2. Tell me R1 hello packet parameters. What is the first parameter is? Area ID. Default area ID
0.
0. Network ID. So network ID of a common link network ID between R1 R2 common link network ID. So which link is the common link between R1 R2?
16.1.1.1.
That network ID, common link network ID 16.0.0.0. Subnet mask
255.255.0.0.
why 255 two times?
Only 1 to 55.
What is subnet mask for 16.0.0.0?
255.0.0.0.
Why 255.0.0
It's 8-bit, so
/8
yeah,
because of
8
/8.
microbits.
Yeah. Hello timers 10 seconds. Dead interval timers 40 seconds. Authentication is optional, leave it. So these all parameters R1 hello packet contains. Now R2 hello packet. Default area ID area 0. Common link network ID 16.0.0.
16.0.0.
Subnet mask 255.0.0.0. Hello timers 10 seconds. Dead interval timer 40 seconds. This is R2 hello packet. Now in R1, if I configured OSPF protocol, in R2 if we configured OSPF protocol between two routers, first state is a down state, neighbor is not established. Second state is what? Initial state, router IDs. In third state, we'll exchange hellos. So R1 will send hello packet to R2. Means with these parameters. R1, it will send this hello packet to R2. You know what R2 will do? R2 will check R1 area ID and R2 area ID. R1 area ID is 0 and R2 area ID is also 0. Area IDs are matching. The next, network ID 16.network and this network also 16.network. Network IDs are matching. Subnet mask is matching. Hello timers are matching. Dead interval timers is matching. Then only R2 will accept R1. You're my neighbor. So by sending a hello packets, neighbor will not form. By matching the hello packet, neighbor will form. Hello packet should match. What should match? Both should be in same area. Area ID must match actually. Area IDs. So R1, R2 both should be in same area. Network IDs must match. Subnet mask must match. Hello timers must match. Then only neighbor will establish. Are you getting my point, guys, everyone? Routers that share a common link become neighbors. Neighbors are discovered by hello packets. This is very important point. Neighbors are discovered by hello packets. So what is the purpose of hello packet in OSPF?
To discover the neighbors.
To discover the neighbors and to maintain the neighbors. Like to become neighbor, following should match. What should match? Area ID.
Area ID, network ID, subnet mask, hello intervals, authentication.
Yeah, they should be matched. Once packets are matching, now R2 also will send hello packet to R1. R1 also will check the same parameters. Okay, area IDs are matching. Network ID, subnet mask hellos. You are also my neighbor. So successful neighbor we called adjacencies. So directly connected device is a neighbor we can say, but hello packets also matching the parameters, then we call adjacencies. So adjacencies are formed once neighbor relation is established. In adjacencies, database details are exchanged. So this is what OSPF terminology. Okay, neighbor and adjacencies. Successful neighbor call adjacency. Can simply call. When they become a successful neighbor by matching the hello packet parameters. It's clear about OSPF terminology? Right. So wildcard mask is done, configuration is done. See about OSPF tables. So OSPF maintains three type of tables. Already we know one table, one type of table, two tables actually. Neighbor table, right? The next routing table, database table. It maintains three tables. One is neighbor table. Neighbor table contains information about directly connected OSPF neighbors forming adjacency. Okay. If you understand neighbor table in this topology, see between R, A and B, hello packets are matching. Parameters are matching, same area, network ID, mask, authentication, hello timers, everything is matching. Then A and B, what is the relation between A and B? Neighbor come adjacencies. B is directly connected, it's a neighbor, and hello packet is matching, then it's become adjacency, successful neighbor. A and C between hello packets are matching. then A and C also become a successful neighbor. Neighbor come adjacency. And router A is sending hello packet to D, but router A is in area 0, router D is in area 10. Area IDs are not matching. Or areas are matching, but network is not matching. But A and D both are directly connected. The just directly connect devices, it will not become a neighbor or it will not become a adjacency. So in neighbor table, what information you can get? You can see only B and C. D is not a neighbor. So that's the point here. Neighbor table contains information about directly connected OSP of neighbors forming adjacency. Next, database table. Database table contains full information. Contains information about entire view of the topology. Like all possible paths. So these all routers information, these all the links information, the router will maintain in one table called what? A database table. Neighbor table contains only the neighbors information, but database table like full picture of the topology, entire view of the topology information. Okay. Routing table contains only best path. Shortest path information will be contains routing table. So these are OSP of tables. Neighbor table, database table, and routing table. Any doubts? Everyone keep heading OSP of metric. Let me explain about OSP of metric calculation. OSP of metric. OSP of metric is what? OSP of metric is cost. Cost formula 10^8 by bandwidth. The same formula you can write like this actually. The reference bandwidth by interface bandwidth. The reference bandwidth is nothing but 10^8 by bandwidth is nothing but interface bandwidth. Same formula you can write like this actually. So what is the default reference bandwidth?
10^8.
Default 10^8. Default reference bandwidth is 10^8. 10^8 means it's 100 Mbps section. So we got now reference bandwidth. I will see interface bandwidth. Generally, what type of interfaces we use? Ethernet. Agree? Or fast Ethernet, serial ports. These all types of interfaces we use. Interface bandwidth means Ethernet bandwidth. What is the bandwidth of Ethernet port?
100 Mbps.
Sorry,
10
it's 10 Mbps actually. Fast Ethernet is 100 Mbps, correct? Fast Ethernet is 100 Mbps. Serial port? Don't know. Right? So how to check interface bandwidth?
why are we taking the interface bandwidth? It is the bandwidth that we actually the link bandwidth, right?
Link bandwidth is interface bandwidth.
Yeah, but we are referring to the fast Ethernet. That
Fast
no.
Ethernet is default is 100 Mbps.
Okay.
So for Ethernet, it's 10 Mbps reference bandwidth, interface bandwidth. Show interface serial 0/0. That can get bandwidth of the serial interface. 1544 kilobits. So it is mentioning kilobits. If we convert into megabits, 1.54 Mbps. Very low speed actually. So serial interface is 1.54 Mbps. Done. So now we got reference bandwidth already, and we got to know interface bandwidth also. So let us implement formula for each interface. Yes, please. Reference bandwidth by interface bandwidth. Reference bandwidth how much? 100 by interface bandwidth is 10. 100 by 10. So what is the cost of Ethernet port?
10.
Reference bandwidth is 100. Interface bandwidth also 100. 100 by 100. So what is the cost of fast Ethernet port? 1. For serial interface, reference bandwidth is 100 by interface bandwidth is 1.54 Mbps. So if you do calculations, you'll get almost it is a 64 actually. 64 is the cost for serial interface. So based on these cost values, OSPF will choose the best path actually. Okay.
What if I have fast Ethernet, but the ISP has given me only 20 Mbps link?
Then 20 Mbps.
Yeah, it is okay. It is the bandwidth of the ISP, right?
Yeah. This example I took, this calculation, this is how. This is default bandwidth for Ethernet port 10 Mbps. So it can be 2 Mbps, it can be 3 Mbps. How much like ISP is giving that you can calculate.
Okay.
Yeah. So let us implement OSPF calculations. Now OSPF configuration in 3 routers. This is the topology, regular topology. R1, R2, R3, R1, R2 connected with serial port. Even R2, R3 connected with serial port. Right? There is backup link from R1 to R3 is also serial link. And R1 LAN port is fast Ethernet port. Even R2 LAN port is fast Ethernet. R3 LAN port is also fast Ethernet. What is the cost? Cost for fast Ethernet?
1.
Fast Ethernet port cost is 1. Here 1. Here 1. WAN link. Serial link cost?
64.
64.
64. 64. 64. Now let us implement OSPF in all 3 routers and target it to 10 dot network. So first step, open the routing table, you can get directly connected networks. router OSP of process ID 123, network space network ID 172.16.0.0, wildcard mask 0.0.255.255, default area ID 0. Like next network is 18 dot network and LAN network. Network 192.168 1.0 0.0.255 area 0. R2. In R2, show IP route, 3 directly connected networks, router OSP of process ID, network 10.0.0.0, 0.255.255.255, area 0, 172.17.00, 0.0.255.255, area 0, and it is 16 dot. Done. In R3, show IP route, 3 directly connected networks, config terminal, router OSP of process ID, network 192.168 2.0 0.0.255, area 0, 172.17.00 255 area 0 and 18. Done. So configured OSP on 3 routers.
The
So
hello
targeted.
and default are timers. We don't need to put it, right?
Yeah, there are default timers, 10 seconds and 40 seconds. Now R1, from R1, how to reach to 10 dot network is the target now. Scenario is R1 to 10 dot network. R1 to 10 dot network, how many paths are available?
Two
Two
paths.
paths. Via S0/0 you can reach. Or via S0/1 you can reach. Via S0/1 to R3, R3 to R2. But OSP will choose the best path based on what? Based on cost. What is the total cost via 0/0? If
64.
traffic is going via 0/0 to reach 10 dot network, what is the total cost?
64.
From serial 0/0 to reach 10 dot network. 10 dot network is
65.
destination LAN.
64 plus
65.
5.
So
64.
64 plus
Plus
fast Ethernet
1.
is 1. Yeah. Total cost value is 65. Like what if traffic is going by 0/1 to reach out 10 dot network? Total cost
129.
129.
129. 64 plus 1. Total 129. So now OSP will choose which is the best path. Via S00 or S01?
S00.
S00. So we can see in routing table, so and so 10 dot network is updated with O route, means OSP of network. The close brackets, administrative
110.
distance is 110 by what is the best cost? 65 via S0/0. Got it? Let us check in R1 routing here. Show IP route. 10 dot network. O route 110 by 65. Exit is 0/0. So like this, we can understand OSP of cost calculations. Like what after some time your best route is failed, 0/0 is down. Then R1, R2 will they communicate? Yes, they can communicate
Yes,
via
through S01.
0/1. then you can see routing table, same O route, same network, a same AD value, but cost will be changed. What is the cost?
129.
129.
129 you can see. And exit point is 0/1. Let me make this link is down. I've removed this best link. It's failed. Now, if we check routing table, see, there is one neighbor is down, neighbor down. Show IP route. Still, we can reach standard network with 0/1 and cost is 129. Got it?
Yeah.
Yeah.
Yes.
So like this, we can understand the cost calculations in OSPF protocol. OSPF metric. Clear? Any doubts? So it's a list of points. Yeah, here. Disadvantages of RIP, link state protocol introduction, OSPF characteristics, router ID, 7 state, neighbor, adjacency terminology, wildcard mask configuration, OSPF tables, OSPF metric. We'll need to continue with OSPF packet types. OSPF packet types are in R1, if I configured OSPF, in R2 configured OSPF. So R1, R2 will exchange hello packets. For what purpose? So hello is one type of packet. What is the purpose of hello packet in OSPF?
To check the neighbor.
Establish a neighbor.
To discover the neighbor, to maintain the neighbor is a keep alive mechanism for every 10 seconds. Agree?
Yeah.
Okay. Once neighbor is established, then what is the next process after neighbor is established? Two-way neighbor is formed. Then what is the next step? R1,
Neighbor,
R2 become a neighbors. Neighbors are established. Then
Then extract.
next start means like which router has to give you first update, right? Okay,
Yes.
that is also done. Master slave is done. Next,
Next start to exchange the information.
exchange. What the exchange?
how do we tell it?
Database, right? So to exchange these database, OSPF will use one another packet called DBD packet. Database details or database description. So in OSPF network, database information is exchanged using which packets?
DBD.
DBD packets. In OSPF network, neighbors are discovered by which packets?
Hello packets.
Hello packets. In OSPF network, what type of OSPF supports for what type of updates? OSPF supports what type of updates? RIP will do periodical updates. OSPF?
Incremental.
Incremental. Incremental update means what?
It updates only when there is a new
When there is
update.
a
Yeah.
change happened, right? Okay. Now we configured OSPF between an R1, R2. It's been 10 minutes. It's been 10 minutes. So no changes happen. Then can you see any update in R1 and R2? I repeat, OSPF is established in R1, R2. Everything is up and running. It's been 10 minutes, but no changes happened. Then can you see any updates in R1 and R2?
No updates.
No updates. So because it supports for incremental updates. If there is any change, then only update. But it's no changes actually. Okay. It's been 20 minutes. No changes. Any updates?
Same thing. No.
No. It's been 30 minutes. No changes. Any updates? Yes. So how OSPF works is for every 30 minutes, half an hour. For every 30 minutes, just database are refreshed. Refreshing the database. LSS are refreshed. What R1 will say, hello R2, our neighbor is established. It's been 30 minutes. Let us cross check whether my database and your database have the same information or not. I'm maintaining so and so information. Are you maintaining the same information? Let us cross check. Just refreshment actually. For how many minutes?
30 minutes.
For every 30 minutes. So what after 30 minutes R1 will do? R1 will send a request. Hello router 2, do you have any new updated information? Is asking the question actually. So for that, OSPF will use another packet called LSR, link state request. LSR packet is used to asking a new information actually. LSR. If R2 really have any update, then R2 will give update. So and so now have update, you take it. So that update will come with another packet called LSU. LSU means
Link state update.
link state update. LSR means link state request. Is requesting is updating actually. So once updated, then R1 will send, yeah, have received your update and thanks. So for that, it will use another packet called link state acknowledgement, LSACK. So these all are OSPF packet types. So each packet has a different purpose. What is the purpose of hello packet? To discover the neighbor, to maintain the neighbor. What is the purpose of DVD packet? To exchange the updates. What is the purpose of LSR packet? Link is nothing but router interface. State is description of interface. LSAs are additionally refreshed for every 30 minutes. Hello packet is used to discover neighbor, to form neighbor relationship. You know, it's a keep alive mechanism for every 10 seconds. DBD, database description, updates are exchanged. Link state request, LSR, used for requesting a new updated information. LSU, link state update, receiving the updated information from neighbors, and link state update, LSACK. Once receiving the update, sending thanks information called link state acknowledgement. It's clear about OSPF packet types?
Yes.
Right. OSPF metric, OSPF packet types. Now let us discuss about areas concept in OSPF. What is exactly areas? Like single area, multiple area. What is the major advantage of OSPF? Advantages in OSPF protocol. Yes.
Bandwidth,
Yeah.
It will use less bandwidth.
limited hop count,
Unlimited hop count. Right. OSPF supports what? Unlimited hop count. Agree? So if a support for unlimited hop count means which type of network size it is recommended to use? For small or larger networks? Large networks. Tell me one, any large network in banking sectors which is having more branches.
Okay.
What?
SBI.
State Bank.
SBI. Okay. How many branches?
100, so
100.
maybe 1,000, maybe more than that.
Like nearly 25,000 branches all over India.
45 plus thousands. No, 45 plus those branches. Okay. Let us take one number. Like there's a 10,000 branches all over India. Okay. Like all branches, or it will be in the same size. Network size will be the same.
No, different.
No. Like the main office, state headquarters, district headquarters, in rural areas, different network size actually. Consider as the main office in Mumbai. And all state headquarters are connected to main office. Head office 1, head office 2, head office 3, multiple. And branches, branch 1, branch 2, branch 3, these all are branches. The main office, head office 1, head office 2, like many head offices. I can't draw a diagram like 10,000 routers, but you assume there are 10,000 routers actually. Branch 1, branch 2, 3, 4, multiple branches, thousands of branches actually, okay? Head office 1 connected to main offices. And all branches are connected to head office. Branch 1, branch 2. And some head office are connected to head office. Some branches are connected to branch. Like. So total how many routers in this picture? I mean total routers in as per our example. 10,000 routers. In Cisco routers, there are 3 categories. Remember? 2600 router, 2800 router, 5000 series, 9000 series. Remember, guys? Yes.
Yes.
So for branches, which router is recommended to use? Branch category, which is 2600 series. For head office, because head office has to maintain all branch traffic, it should be some high. So it should be 5500 category. And main office, so main office has to maintain all branches on all headquarters traffic. It should be very high-end device. It's ISP to category 9000 series. So this is a hierarchy design actually. What is the difference between 9000 series router and 2600 series router? Uh, 2600 routers ports might be Ethernet port or fast Ethernet like 10 Mbps and 100 Mbps ports. And CPU will be low power CPU. Storage also very low. So hardware and performance wise is low actually. So that is why it is recommended only for branches. What about 9000?
It's a
The
service
ports
provider
big.
router.
Service provider router. Each port can support giga, 10 gig, 20 gig, 30 gig port, very high and Ethernet fiber ports. CPU power will be very high CPU power. storage, more storage, crores of rupees router. Okay. So we have hierarchy design is like that. So main point is in 10,000 routers to enable communication between these all 10,000 routers, which routing do you recommend? Do you recommend static routing?
No,
No. Do
only
you
for
recommend
small
RIP
networks.
protocol?
No,
No. Then which protocol is recommended?
OSP.
OSPF. But if you configure OSPF, the thing is each router should maintain full picture of the topology. There is a rule in OSPF. With respect to each router should maintain what? Full
Full
picture of the
full.
topology. So main office router should maintain how many routers links information?
10,000.
10,000. If main office router maintain 10,000 routers links information, then what about head office routers?
They will
10,000.
also
Head
maintain
office.
10,000.
Head office routers also should maintain
10,000.
10,000 routers links information. Then what about your branch routers?
So 10,000.
Thing.
Branch routers also will maintain 10,000 routers links information. So each router, each branch router should maintain 10,000 routers link. So branch router don't have much capability to maintain the larger networks. It is low CPU actually. If the branch routers are maintaining 10,000 routers links information, then routers will generate a log notification messages that is I'm running out of memory because my routing table is too big. So performance wise is going to be down. Agree? So why branch router should maintain 10,000 routers? Because all routers come in one topology, all routers in one group, correct? 10,000 routers belongs to one group. We call it as area. Area is not like a Hyderabad, Bangalore, not like that. Area means in OSPF, as per OSPF terminology, area is a number of routers comes under one domain, one group called area. What is the default area?
0.
Area 0. In area 0, how many routers are available right now?
10,000.
10,000 routers. Then each router should maintain how many routers links information?
10,000.
Then what about your branch routers performance? If branch routers also need to maintain 10,000, then your branch routers will be down now. Agree? Then what is the best solution here? How to overcome this issue? I'll give one solution. Tell me, do you agree or not? What I'm doing is, I'll try to install 9,000 series routers everywhere. If it's a 9,000 routers, then it can be managed because high capacity, high power, high storage. Our issue is resolved. Do you recommend?
Cost.
It's too
Costly.
costly.
Costly. Not only that point, actually, one more point is in rural area, 9,000 series means crores of rupees router we need to install in rural area. A basic network engineer can manage this router 9,000 series router configuration and maintenance? No. A specialist expert required. A senior network engineer might require to installing and maintenance, right? So everywhere is expert is required actually. If it's normal 2600 router series, then with the help of the seniors, the junior engineers also can manage it. But 9,000 series router experts required. And physical security is also required. Agree? So
Yes.
this is not a best solution. Then Cisco recommends hierarchy design. 9,000 only in main office, 5,000, 2600 like that. If you maintain like this, okay, but problem is what OSPF will tell each router should maintain full picture of the topology. Each router should maintain within the area routers information. In area 0, there are 10,000 routers, then each router should maintain 10,000. So OSPF is designed and divided a single area into multiple areas, a single group into multiple groups. Now one group having 10,000 routers, then each router should maintain 10,000 routers. Then your branch routers will be go down. Why we need to do like this? No need. We'll do one, we'll split it. Single area divided into multiple areas, multiple groups. So few routers in one area, one group, another few routers in another area, like few more routers in another area. But there is a rule actually. What is the rule? One area should be backbone. Means one area must be area 0. Without area 0, we cannot design actually. I'm keeping head office or main office is area 0. This area 0 we called backbone area. Backbone area, area 0. In remaining, we can give any number, area 1, area 2, area 3. Example, area 10, area 20, area 30, like this. All areas must be connected to area 0. Area 10 must connect to area 0. Area 20 must connect to area 0. Area 30. Network architecture will design like that. You need to understand all, okay? But what is the advantage of these areas? Why we are dividing? See, after dividing area 10, now as per this diagram, in area 10, how many routers are available? As per this diagram, in area 10, how many routers?
3.
3.
How many?
3.
3. Then each router should maintain within the area routers links information only. No need to maintain 10,000 routers links information within the area. So B1 router should maintain only 3 routers links information. B2 router should maintain only 3. B3 also only 3. Each router should maintain within the area only. So each area is recommended to install 30 to 40 routers. Each area is recommended. More than 40 also you can do, but again the same issue will come action. It is 30 to 40 is recommended action. So this is a areas concept in OSPF protocol. What are the issues with OSPF single area? If all routers in one area, then branch routers, I'm running out of memory because my routing table is too big. So to minimize the routing table and to improve our network performance or router performance, areas are designed actually. And head office routers will say I'm receiving too many updates, too many times updates, too many LSAs. I'm running too many times algorithm. So these are the issues with OSPF single area. To overcome, OSPF network design is divided into multiple areas. One area has to be designated as area 0. That area 0 we called backbone area. Remaining all areas we call non-backbone areas. Okay. So you can divide like this, area 0, area 1. So areas to minimize the routing table size and to improve router performance and network performance. Any doubts? Yeah.
I have a doubt.
Yes, please.
For all the small branches that we have, will the area code be default 0 or will it take area 10, area 20?
Area 10, area 20. Backbone should be area 0, which is the main office.
Okay.
And area code, I mean area numbers, you can use any number between 1 to 65,535. You can use any number.
So the head offices will have two areas, right? Area 30 and area 0.
Excellent. Correct. Routers which belongs to area 0. Routers which belongs to area 0. Those routers we called BR. Make a heading. OSPF router types. Routers which belongs to area 0, those routers we called BR. Backbone routers. Means almost 9,000 series routers are backbone routers actually. Routers which belongs to area 0, those routers we call backbone routers. Routers which belongs to non-backbone area, means area 10 routers, area 20 routers, area 30 routers, those routers we call IR, internal routers. Routers which belongs to non-backbone area, or we can call regular area. Regular area means non-backbone areas. So those routers we call what? IR, internal router. Now what about head office router? Like head office router, is it belongs to area 10 or it belongs to area 0? Routers will connecting to different areas. Head office router is a part of area 0, is a part of area 10. So router which connect to different areas. Those routers we called ABR, area border router. A router which connecting to different areas, call it is ABR, area border routers. Backbone router, internal router, area border routers. It's clear? Router 1 connected to router 2, router 2 connected to router 3. In router 1, I configured RIP version 2 protocol. In router 2, I configured OSPF protocol. In R3, I configured OSPF protocol. R2, R3, will they communicate? Yes, they can, right? Because they're running same protocol actually. What about R1, R2?
No.
No.
No, they don't communicate because of they are in
Different protocols.
different protocols. Yes. If I configured RIP version 2 in R2, then now R1, R2 will they communicate? Yes, we can run multiple routing protocols in one router. You can configure RIP, you can configure OSPF, both we can run at the same time, no problem actually. Now R1, R2 will they communicate? Yes.
Yes.
With RIP protocol. R2, R3 will they communicate? Yes. With OSPF protocol. What about R1 and R3? So from R1, one of the user want to access or want to communicate with R3 user. Will they communicate? No.
No.
But I need a communication. Then how? Solution is change or configure OSPF here also. Then all routers will start communicating with OSPF. Agree? But my requirement are you'll configure here RIP protocol. Then all routers will communicate with RIP only. But my requirement is I don't want to change RIP protocol in R1. It should be this is my older network, very old network. So I'm running with OSPF. This is my new network. Then I configure OSPF. Then how the new one and old one can communicate? So there is one mechanism which we call redistribution. If we configure redistribution, then different protocols also can be communicated actually. So what redistribution will do? RIP networks, it converts into OSPF. And whatever OSPF networks convert into RIP. Then R1 will understand R3 also RIP. R3 understand R1 is also OSPF. So the middle one will manage it actually. How? RIP networks into OSPF. OSPF networks into RIP will convert. So that process we call what? Redistribution. So what exactly R2 is doing now? A router which enable communication between two different protocols. It's enabling communication between RIP to OSPF now. So the device, a router which enables communication between two different protocols, we call it is ASBR, Autonomous System Boundary Router, ASBR, Autonomous System Boundary Router. So these all are OSPF router types, BR, IR, ABR, ASBR. Can anyone explain what is BR, what is IR, ABR and ASBR? If you understand. BR means
Backbone router.
backbone router belongs to which area?
Area 0.
Area 0, which is backbone area. Okay. IR means
Internal router.
internal router which belongs to which area?
Non-backbone.
Non-backbone area, or we can call it regular area. Correct. What is ABR? Area
Border router.
border router. What ABR will do? ABR will connect to different areas. Area 0, area 10, area 0, area 20. Like the head office routers are ABR routers connecting to different areas. What is ASBR? Autonomous System Boundary Router. What ASBR will do?
Redistribution between different protocols.
Yeah, it's enable communication between two different protocols. So types of routers: BR, backbone router, router which belongs to backbone area is called backbone router. IR, internal router, the router which belongs to regular area, which is non-backbone area, is called internal router. ABR, area border router, which shares to different areas, is called ABR, area border router. ASBR, autonomous system border router, A router which is connected to different protocols is called ASPR. Then, yeah. So is all the terminologies, is all the points you should remember when you are working with OSPF protocol in your live networks. If you are not using OSPF, then no problem. But mostly 95% we use OSPF protocol only in real-time action. Even in for Cisco, who is preparing or who is planning for write the Cisco certification exam, so you'll get mostly questions from OSPF one actually. Let me project this list of points in OSPF. Just cross-check with these points. If you have any doubts, let me know. Yes. The link state routing protocol, OSPF characteristics, OSPF router ID, OSPF 7 states, OSPF terminology means what is hello packet contains and what is adjacency. That is the terminology. Wildcard mask calculation, OSPF configuration, OSPF 3 tables, metric calculation, packet types, hello packet, DBD packet, LSR, LSU, LSACK, single area, multiple area, and OSPF router types, BR, ABR, IR, ASPR. These all are OSPF terminology. So successfully we have completed OSPF protocol. Any doubts?
Any problems with OSPF?
Complexity, designing more complex because we need to design the areas, dividing into multiple area, and all non-backbone areas must connect it to area 0. So complex configuration. CPU utilization, it's running algorithm multiple times. This is the problems in OSPF actually. We can't implement OSPF simply. So we need some design. 30 to 40 routers in one area. Define one ID. Area 30 or 40 something. That area should connect it to backbone area. Like so, there is a design in OSPF that is complex actually. And more CPU utilization also because it runs algorithm multiple times. No OSPF 7 states. So there is more mechanism in OSPF.
We have taken an example that the R1 to R2 link fails and the traffic will go to R3 and come to R2. Will it be
Correct.
seamless or like there will be user will experience a downtime?
Nothing. No, seamless they can communicate actually. User will not experience any downtime or any without knowledge of, without any down or anything user, network will be established. Because these protocols will maintain the tables. Whenever link down, it run algorithm, it will check into a table, immediately go with another link. Very few seconds, if it is very few seconds. So you have internet connection at your home, right? Yes. So continuously you're accessing internet. Do you think it is going via only one link? No. There might be failures, but still you're getting internet. It is routed to another link, but we don't face an experience actually. Protocols will manage that. Okay. All good. So one more time, try to practice an OSPF protocol. And tomorrow we'll try to compare 3 routing protocols like RIP, OSPF, and EAGR. I'll give some introduction of EAGRP protocol. We'll compare 3 routing protocols and we'll finalize which routing has more advantages and which protocol we use in real time. So in first hour, we'll try to complete this routing part. And next, we'll start introduction to LAN technologies. Switching part will introduction. Thank you. Have a good day. Yeah, thank you, Jaydeep. Wish you the same.